We're going to be looking at some conditions that have to be taken into account. Now, you often find that, uh, well, you would think that computers are clever, yet they, like I mentioned before, they are really stupid machines, and they can only do certain things depending on what you tell them, and then also depending on certain conditions. And so you might have a situation, if you have to think about it, in a household environment, you might be asked to go and buy eggs. Might be your mother, your wife. They ask you, please go buy some eggs. But there are certain conditions you need to take into account. For example, they might say to you, please make sure that the eggs are large. Yet, if the eggs should be white eggs, then it doesn't matter what size it is. It could be small, medium, or large. But it might be because there's conditions there that the white eggs are maybe duck eggs or are more tastier eggs compared to your normal brown chicken eggs. So if you go to the shops and you get there and you see, well, the eggs are brown ones, you would have to be restricted to only buy large eggs. Yet if you see that they are white eggs, you might have the option of large eggs, mediums, or small eggs. So these conditions are often looked at in programming, and that's a basic sort of form of artificial intelligence. And these conditions that we're looking at is called the if statement, also known as the if else statement. And that's what we'll be looking at. All right, so if you look again, I've got the basic format of my program illustrated over here. What I am going to do is I'm going to have an int x over here, which is equal to 0. So the purpose of this program is we want to again find a number squared, but we want to make it a restriction in terms of that the number that the person enters in to be squared must be between 20 and 50. Reason being, you might find that a person is able to do the calculation for a number squared up to the value 20 and wouldn't be able to, or wouldn't need to do calculations, or wouldn't be able to do calculations for 20 and higher. At the same time, we've restricted it with the upper limit of 50. As we saw before, squaring a number that might be too large could cause overflow issues, and the last thing we want to happen is that the computer would bomb out. Okay, so we've got to assign a variable x, which will be used to square, and then we're going to have a printf statement. Enter a number between 20 and 50. And then we'll have a scanf %d, comma, ampersand x. Right, and so the first thing we want to check for is whether x is larger than 50. If x is larger than 50, what do we want to tell the user? Well, we want to tell them that the number that they've entered is too large. Okay, so the if statement appears as the following. If, open brackets, x is larger than 50, close brackets, and we've got to open curly brackets and closing curly brackets. You'll notice that there isn't any semicolon after this bracket over here, because it's a continuation into this open bracket and close bracket scenario we've got there, just as we've got in the int main void statement. Okay, so again, you'll see it automatically does this indentation just to lay out the code in an easier way to follow. Okay, printf, and we tell the user the number is too large. You'll see that I've put that /n in the beginning and at the back. And the reason for that is that just to have a new line to separate between the number that you've entered and again the statement, and again to have a line after the statement. Okay, well let's run this and see what happens. Okay, enter a number between 20 and 50. Let's try number 15. Nothing happens, exit code is 0. Well, we didn't expect anything to happen because the only thing we said that some output's got to be given is if the number is larger than 50. Let's try something like 30. That still doesn't give us anything. Let's try again. Let's try the number 60. The number is too large. So we know that part of the program is working. Okay, let's continue with this. So now we're going to have another condition we need to look at, which is should x be less than 20, because we want to have a number that's between 20 and 50. So if x is less than 20, and yes, I do know that there are times that you can have an if statement without these curly brackets, yet you'll see later on that and this is something I've seen so often happen, is that these curly brackets are not inserted, another line or statement is inserted, which makes the whole code doesn't run. And this creates, again, a syntax error. So the easiest way to make sure that you don't make any problems is to always have these open and close curly brackets. In this way, you're ensuring that you're not making a mistake and that you're minimizing the syntax errors, and therefore also able to minimize having to debug and find these problems. It saves a lot of time. Right, so if the number is less than 20, printf, again a new line, the number is too small. Okay, let's run this and just see if it happens. So we enter a number, let's say 30, and then nothing happens. That's great. We enter a number, let's say 60, the number is too large. Let's enter a number that's less than 20, so let's make it 10, the number is too small. So now we know that is now all working. Okay, the issue is that we've got a Goldilocks scenario. We need a number that is not too big and not too small, but just right in the middle between 20 and 50. So we need to now take into account numbers that are between 20 and 50. Right, so we can have another if statement over here. So if x is larger than 20, then obviously that will make sense. But we need to take into account that x needs to be less than 50 as well. Now for this we need what's known as the AND statement, because both conditions have to be true. So AND as a double AND sign that you're familiar with. And so the other condition that needs to be taken into account is x needs to be less than 50. Now very important is that when it comes to if statements, the whole condition that you're looking at needs to be in brackets. So in other words, we need to place a bracket over there in the beginning, we need to place a bracket over there at the end. Okay. So if this should happen, then we need to say printf in a new line, the number squared is, and we're making a percentage %f and a new line, and that is power of x comma 2. Now, keep in mind that this closing bracket over here is just for the spell function. So because there is a printf statement that's got the open bracket over there, we need a closing bracket over here as well. Okay, now again, we are using an AND function over here. Now if you look at logic gates and you look at the theory behind it and look at the truth tables of logic gates, your AND logic gate has to have all the conditions of inputs need to be 1 for the output to be 1. So in other words, if you look at this statement over here, this condition needs to be true and this condition needs to be true for this statement to be executed. We can also have the OR statement where this condition is true or this condition is true. So if either of these two conditions are true, it will then execute this line as well. We'll have a look at that in a minute. Okay, so let's run this and see what happens. Okay, so enter a number between 20 and 50. Let's type 20. Well, nothing happens. Okay, we'll have to address that now. Let's say 15. Number is too small. Let's look at 60. Number is too large. Let's look at 30. The number squared is 900.0. Okay, so our program seems to work. Like I mentioned, if we want to use the OR function, we can do that as well. And that is this double line. So it's a shift and then one of your keys on your keyboard. On my keyboard it is backslash. It actually, if you look at it very closely, you'll see there's a space, a small divider between these two lines, or between this actual line there's a small horizontal divider over there, and again for this one there's a small horizontal divider over there. So that represents OR. So as we said, this condition has to be true or this condition has to be true. Let's see how that would run in this scenario. So if we put in, let's say 15, it tells us the number is too small and the number squared is 225. The reason the number is considered to be too small is that, I mean obviously it is 15 is less than 20, but this condition is also true because x is also less than 50, this statement is being executed. Again, if we run it and we enter a number in between, like 30, because so now we are told that the number squared is 900. So the first statement over here is not being executed because 30 is not larger than 50. The second statement over here is not being executed because 30 is not less than 20. The third statement, x is larger than 20 or x is less than 50. So both of these conditions are actually true. So therefore this command gets executed. Okay, but then what happens if we put in a larger number like 60? Again, the number is too large and it's showing that this the answer is 3600. And it's saying it's large because x is larger than 50. But also x is larger than 20. So therefore it will also show this. So it's very critical to know the difference between your AND and your OR operators to be able to get the answers correctly, because that will influence it. Okay, now one of the things we have to look at, and that we didn't take into account and we saw as an error, is what happens if we enter in the value 20 or 50. I mean, if depending on what you want to or how you want to define it, the number needs to be between 20 and 50, whether it includes the numbers 20 and 50. That's up to you to decide. But if we want to include it, we can have the operator over here as larger than, equal to, or less than or equal to. So in this case, if we had to run it and we had to type in 20, it tells us the number squared is 400. So this is our larger than equal to, and this is our less than or equal to operators. Something else that you might want to take into account is what happens if you want to say that x should not be equal to 20 but should be less than 50. Well, not equal to is represented by exclamation mark equals. And so in this case, if we run it now, what about 20? Well, nothing's happening. What about 21? And tells us the number is 441. So this condition is true. Well, x is not equal to 20, it was equal to 21. And this condition over here is true. X is still less than 50, so it's able to tell us what the number squared is. So that's if you want to use the not equals operator. Essentially, just to summarize over here, we've got the less than equal operator. That's less than and equal. We've got the larger than equal operator, so that's larger than and equal. We've got the larger than operator, that is larger. We've got the less than operator, that's less. We've got not equal to, which is exclamation equal, that's not equal to. Then what we also looked at is your AND operator, so that's AND. And we've looked at the OR operator, which is your OR. So these are the basic operators that we've looked over here. Right, so now if you look at this, there's an issue with this program in terms of we've had times where this expression was outputted, telling us the number is too large, and then we get a number that is squared, in terms of we use the incorrect operator over here for OR, for example. But if the number is too large and it outputs the number is too large, let's say you put in 60, does it have to check if x is then less than 20? Does it have to check if x is between 20 and 50? It would be a waste of time. There's no need for that because it's already identified that x is larger than 50. One of these conditions are true. Therefore, it's outputted the answer over here. So there's a way that we can say with else if. So how the else if statement works is that if x is larger than 50, or in this condition, if x is larger than 50, then all the other statements below it won't be executed if it's got an else in front of it. If x should be larger than 50, it would execute this line, but not everything below it. But if it is, let's say, less than 50, and this condition is not true, then obviously it will go to the next statement and check if that condition is true. So as soon as one of these conditions are true, then it will execute that, but not continue with it. And we could have another set of else if statements over here. But obviously, if x is larger than 50, well, if x is not larger than 50, or x is not less than 20, it means it must be between 20 and 50. So we are able to get away with this with just an else statement. So this last else in your else if statement is the default expression that is going to be shown. So in other words, if the first condition is not true and goes to the next condition, and that condition is not true and goes to the next condition, and you could have hundreds of different conditions, else if conditions over here. But if all of them should fail, then the default thing would be the final else statement, which would be to then tell us that the number squared is whatever the answer is. So let's run it and see how that works. So if we use 15, it tells us the number is too small because it came there, x was not larger than 50, so this statement didn't execute. Therefore, it looked at this statement. Was x less than 20? Yes, it was. It executed this statement. But now, because this statement was executed, it doesn't have to execute any of the other commands in the else if structure below it. You could have over here a printf statement saying end of program if you want to. Okay, so if we run it again and we enter in 15, it will tell us number is too small because it's checked over there it's not larger than 50, so it didn't have to execute this statement. It then checked if x is less than 20. Yes, it was. It told us that the number is too small, and therefore this else statement was then skipped. So whatever was after the brackets of this else statement was skipped because one of the conditions were executed, and then a final line of end of program was executed. Okay, let's have a look at if we took a number that was between. So let's say 30. So 30 tells us that the number squared is 900 because 30 was not larger than 50, so this statement didn't execute. 30 was not less than 20, so it didn't have to tell us the number is too small. So both of these conditions were false, and therefore it went to the default of pointing out that the number squared is 900. Again, end of program was displayed over here. That's just to show you that this line was still executed as it wasn't part of the if else statements and brackets over here. Okay, let's run again and let's take a number 60. The number is too large. It started off over there, it saw that 60 was larger than 50. It told us the number is too large, therefore this else if section over here, that wasn't executed, and therefore this else section over here was not executed. Okay, so we could have another if statement that starts over here. For example, it might be if y is equal to 30, then another set of commands can be executed over there. So that's another operator we've got to take into account. Equals. Okay, that's equals. Now what's very important is that it's a double equals. It's not a single equals that we have over here. So whenever we do a comparison between two numbers in the if statement, it needs to be a double equals. Okay, so in this case we could say if x is equal to 30, I'm not going to go with y because it's another variable to declare and stuff, another input I've got to take into account. So we can then say printf you have a middle number between 20 and 50. Actually, is that true? No. What's the middle of 20 and 50? That would be 35. Okay, so we just change this. If x is equal to 35, then you have a middle number between 20 and 50. So let's run that and see. So we're going to try 30. It just tells us the number squared is 900. It's the end of program. Let's try again and try 35. Alright, so if we look at the output over here, let's just make this a little bit bigger, this screen. So the number squared is 1225 because if we look at this piece of code, 35 wasn't larger than 50, it wasn't less than 20, so therefore it's executed what it was. But now because we've got another if statement over here that is completely different to the if statements we've got above over there, it's also checking if x is equal to 35, and therefore it's able to tell you that it's a middle number between 20 and 50. Okay, so this basically shows us how to do the conditions with the if statements. Like I said, it's the very basics of artificial intelligence. We looked at the less than and equal operator. We looked at the larger than and equal operator. We looked at the larger operator, the less operator, the not equal to operator. So that's all one single O over there. We looked at the AND operator, the OR operator, and the equals operator. Very important again, make sure that you've got a double equals when comparing two conditions that are between brackets. A common mistake that gets often made and causes that things won't work. As a matter of fact, let's actually just give it a try. Make a single equals over there. Let's run it. Let's put in a number, again 30. For 30 says you have a middle number between 20 and 50. So with a single equal sign over there, it doesn't actually work. And again, you can be sitting for days, sometimes weeks, trying to figure out why a piece of code is not working, and it's because of a small typo, like an equal sign like that makes things just not work as they're supposed to be.